Hey guys, welcome back to my channel. I hope you all are having a wonderful day. Today I will be going through position time graphs. Without any more talking, let's just get started.
Okay, so like I said, there are two different graphs of motions or motions of graph. And for this one, we have velocity time graphs. And I feel like there is so much more information on velocity time graphs than there is for position. So there's a lot more to talk about for here. And so let's just get down to the basics. The slope for a velocity time graph represents acceleration. I'm gonna show you stuff. So the slope represents acceleration. Why? Because slope again is rise over run. And rise over run for a velocity time graph, the y-axis will be velocity, x-axis will be time, rise is y, run is x. So acceleration is equal to velocity over time, so that is why slope represents acceleration for a velocity time graph. Okay, so I already told you guys that slope represents acceleration. So basically, let's say you have a graph that looks like this. This is velocity and this is time. Okay, and then you have a line right here. Okay, so this will represent a constant velocity because it is constantly on this line for velocity. So let's say it went 20, 40, 60, 80. It is at a constant velocity of 40 because it is on this line. Okay, so that represents a flat line for velocity would represent a constant velocity. And that makes sense because, yeah, it's a velocity time graph and it's constantly on that. So that also means it has a zero slope. Why? Because if the velocity is constant over a period of time, it's going to be the same. Because there is no rise over run, it's flat. And there's no acceleration. Sorry, I said that backwards. If there is no acceleration because it is a flat line, it means there is no slope because the slope is equal to acceleration. There's no acceleration, there's no slope. So that's that. So let's see. Let me draw you guys these examples that I use to keep myself sane, honestly, because physics is hard. So let's say you have a line going up. That would represent acceleration. You have a line that's flat, it's going at a steady speed and a constant velocity. And then you have a line going down constantly. That would represent a deceleration. So basically that is a acceleration but just downwards. So still accelerating but just in the opposite direction. Then you have a curve. So that means it is increasing its acceleration. And that is one graph that helps me keep sane. And another one that I use very often is this one. So let's see, 3, 6, 9, 12. That's velocity and this is time. So let's say it goes this way. Acceleration, like I said, would be 0. Like I said right here. Okay, so just like I said, acceleration would be 0. And the velocity would be constant and positive. Because it's going forwards in a positive direction because these are positive, so the velocity is obviously going to be positive. If we were really focused, it would be a 6 and it would constantly be at 6 because it's flat. And then if we had it going up like this, it would be accelerating. Velocity would be positive because it's on the positive top, and it would be speeding up. Okay, and so let's draw another flat line, and that would be the exact same thing right here. No acceleration, velocity is a positive and constantly positive. And then let's say it was going down, so now your acceleration would be negative, and just like this, but the other way, so it would be decelerating. Your velocity is positive, it's not constant, and it is slowing down because it's moving downwards. So those are the two kind of like representations that help me kind of like keep it together and let me like kind of like remember stuff and all that. But let's talk about average acceleration. For a velocity time graph. So you have to calculate your slope line to get your average velocity. And your slope equals your average velocity, like I literally just said. I'm just gonna summarize it. So basically, let me draw this because y'all will probably most likely see this. We saw this in our quiz on Friday. So yeah. Okay, let's say we had v1, velocity, and velocity 2. Time 1, time, and time 2. Okay, so we would want to, oopsies. Let me draw them a little bit up. So you would want to trace it to that point so you can get your first point, and you wouldn't want to trace the second one to another point on the line that is convenient for you to calculate so that you can get your slope. So to get your average velocity, the formula is delta velocity over delta time. And delta basically means a change, I'm pretty sure, maybe. I have no idea. But what I do know is what these represent. The delta velocity is final velocity minus initial velocity. So basically, where the final velocity of the line ends and where it first started, basically. And then your delta time would be t2 minus t1. So basically this minus this and this minus this over each other would give you your acceleration. Okay, so let's put some numbers. Let's say t2 was 9 and t1 was 3. Let's say this was 3 and this was, I don't know, 10. So final velocity over minus initial velocity would be 10 minus 3, which is 7, all over t2 minus t1, which is 9 over 3, and that's 6. So the slope would be 7 over 6. So that's your rise over run and your average acceleration. Okay, one last thing before I round up this video. I believe maybe. This video is gonna be long. I told y'all velocity is a lot. Okay, so if your line is straight but is not horizontal, a straight line but not horizontal, that represents that the object is moving with a constant acceleration. So it is a constant acceleration. If it has a positive slope, the object is moving with a constant acceleration. So the object's velocity is moving up with a constant acceleration. If you have a negative slope, your object's velocity is going down with a constant deceleration in this case. You could say acceleration, the right word would be deceleration because it's negative and it's going down instead. So that's about it, I believe. This is a velocity time graph, and so let's just go over it. So a constant on a graph is a straight line. For velocity, it would be a constant velocity because again, it is a straight line for velocity on the y-axis. So it's going to be a constant velocity, the same velocity, as long as it's straight. So lines A and E would maintain a state of motion, so basically a constant velocity throughout because they are flat and straight lines. B and C are accelerating because velocity changes over time, so it's accelerating because the velocity is going up or it's going down, so it's showing change over time. For D, at first it was accelerating, well decelerating, but still accelerating. There was an acceleration occurring and then it had a constant velocity. It got straight, so it was going down and then it went straight. For an object to not move, it has to be on the 0 for the y-axis. So basically you see how these have a constant velocity. That doesn't mean they're not moving, they're just constantly moving at that same velocity. If however it was on this time little line at 0, that means the object is not moving at all. So it's not at rest or anything, it's literally just not moving. Okay, so when the line crosses over the x-axis for a velocity time graph, it changes direction. So basically wave velocity, a positive doesn't mean it's bigger than a negative like you normally would on a regular graph, because normally you would be like, oh, a positive 3 is greater than a negative 3. For velocity, it just means a change in direction. So for positive, that means you're moving forwards, and if you cross over the x-axis to the negative, it means you have gone backwards for velocity. So I could be walking. Actually, no, I'm gonna use the example my teacher gave me because that's what she used, and that's what helped me to understand this finally, literally last minute. So let's say I have a car and I am driving, so I am in the positive range. So let's say I am C. So when I cross over the x-axis, let's say that is a stop sign. That is not what a stop sign looks like. Okay, a stop sign. I reach a stop sign. So I'm moving forwards at first on the y-axis, and I reach the stop sign. I stop for a second and I switch directions, and now I am moving backwards. Doesn't really make any sense, but it does. Well, really, physics is just, there's a lot that doesn't make sense, but we make it work. So basically, it's a change in direction. Positive and negatives don't really matter. It just shows you what direction it is moving in. And once you let that sit in, it kind of just like, it all works out. And the last thing would be B is the most shallow, so it has the least acceleration. Again, my picture doesn't really help you see that, but you can look up like pictures of like these like velocity time graphs, and it'll like show you like how it actually looks, and you can see like which one is shallow, which one is deep, and which one is accelerating faster.
Thank you for watching till the very end. I really do appreciate it. I hope you found this video helpful and learned something new. Feel free to like, comment, and subscribe. Don't forget to turn on post notifications so you don't miss out on another upload. Bye.